All right, we want to be able to identify the parts of a wave, including the amplitude, crest, trough, and cycle. We want to be able to find frequency given a period, and we want to be able to identify the amplitude and period from either a graph or a situation. So looking at this graph here, we're first trying to find the amplitude of this wave, and the amplitude is how high the graph goes or how low the graph goes from its center position. Now we have centimeters right here, and I can see these are all going by ones, so we're going up 2, down 2, up 2, and if we kept going, we would go down 2. That's going to be the amplitude. So that's going to be 2 centimeters. So this is the amplitude. Then we have the period of the wave. Now the period of the wave is the time it takes to complete one cycle. So what we want to first do is identify where our cycle starts and stops. So if I start at 0 seconds, that's a really convenient spot because wherever the cycle ends is going to be the total time for one cycle. So here I'm going to go up and then we go down and then we go up. Once I hit this, the cycle is going to start repeating itself. So this is what a cycle looks like. And if I take a look here, it looks like we're going by 0.1, 0.2, 0.3, 0.4, 0.5. This is going to be 0.6. And I know this is hard to see, but that's in seconds. So 0.6 seconds. So this is one cycle, okay? And this is period, which is the time for one cycle. And then we want to know the frequency of the wave. Well, the frequency of the wave is given by 1 divided by the period. It's just the reciprocal of the period. So if we do this, we have 1 divided by 0.6 seconds. Okay? And that's going to be approximately 1.7 hertz. Next, we want to be able to calculate the speed, wavelength, and frequency of a wave given the values or a displacement versus position graph. So let's take a look. They want to know the wavelength of a wave. Well, this is very, very similar to finding the period. We're going to first identify what one cycle is, but what happens is on this graph here, I now have distance instead of time. So I'm going to start this one cycle. So I go up and down and up. So this is where my cycle ends. Okay, so this is one cycle. Okay, the wavelength is the distance for that one cycle, so that's going to be 0.4 meters because we're in meters here. Next, if the frequency is 20 hertz, what is the speed of the wave? So once we know that it's asking for the speed of the wave, you need to use the equation speed equals frequency times wavelength. Well, they give you the frequency, that's 20 hertz. And we calculated the wavelength, that's 0.4 hertz, or sorry, 0.4 meters. Therefore, the speed is going to end up being 8 meters per second when you multiply these two. And then the last thing on this page is this standing wave. So what we want to be able to do is be able to find the frequency, wavelength, and the speed of standing waves. So if I take a look here, I have the fourth harmonic, and the length of the string here, length equals 6 meters. And we know that the frequency of the fourth harmonic is 20 hertz. Now, if it wants to know the wavelength of the standing wave, okay, well, we know the wavelength for any frequency is twice the length divided by the number of that harmonic. Well, we have the fourth harmonic, and we want to do twice the length, which is 6 meters, divided by, it's the fourth harmonic, so this is 4. So we get 12 divided by 4 is going to be 3 meters. Okay. Now we know this is a fourth harmonic because we have the 4 loops. Next, what is the speed of the standing wave? Again, this is just like what we did before. Once it's asking for speed, we know we're going to use this equation. So we know that speed equals frequency times wavelength. Okay? And they give us, for the 4th harmonic, they give us that is going to be 20 hertz. So they give us the frequency, and we just solve for the wavelength. That's 3 meters. So the speed is going to be 60 meters per second.